Nation, here we are with our 4 o'clock segment from the NuMinds Vault. Today I'm very excited and happy to present a session from one of our classic courses called Mathacadabra, the union of magic and math. For this particular lesson, we're going to start back in ancient history with a legend, with a myth from Chinese history. We're going to journey into modern times. And along the way, we're going to make some stops in Germany. We're going to hit Ben Franklin. It's going to be a pretty exciting little adventure that we go on here. But I have to start with a story. By the way, I'm standing up. I know that we've been sitting down to deliver most of the lessons, but honestly, I prefer to teach while I'm standing up. So I'm trying a little different arrangement today. I should be easier to communicate with you guys and show you some things I want to show you. Okay, so today's lesson begins with an ancient from the country of China. So listen in. So I'm paraphrasing here, okay? So once upon a time in ancient China, there was a major river that had flooded. And so many villages along the river were in grave danger. A lot of things were in danger. And so the people of the villages gathered together and they went out to the river, and they knew that there were some rituals they could perform to appease the river god so that perhaps he would recede and leave them in peace and leave them safe. So all of the villagers went out to the river that was flooding, approaching their villages, and they performed this ritual. And when they performed the ritual, the strangest thing came out of the river, walked out, made a few circles, and then plop, back into the river. So they thought, that was strange. What was that? A turtle? What? A turtle? What's going on here? That was odd. So they go, okay, that didn't work. The flood is still rising. Like this is not working, people. We're desperate. So they go out the next day and they perform the ritual again, a different number of times. They weren't sure, like, okay, how many times do you think we need to perform this ritual so that the flooded river subsides? So they go out there the next day, they perform the ritual, and that same little turtle pops out. And he walks, he makes a few circles, and then he plops back down into the river. And everyone's befuddled, dumbfounded, bedazzled. They don't know what to make of this crazy turtle, right? And so, but someone notices, like, you know what? That wasn't a regular turtle. He had some like strange, interesting markings on his back. And that could mean something, maybe. Maybe it's a message that we need to decipher a little bit. So they go out the next day and they say, okay, find all the smartest people in the land, bring them, so that when the turtle comes out this time, they can take a look and crack this code and figure out what's going on with the turtle. So they brought all the wisest people they could find in that region, the teachers, the professors, the wise men. They brought the monks and the yogis down from the mountains, from their caves, who could analyze the turtle and take a look at it. So they went down to the river the next day. They performed the ritual. And sure enough, just like the other previous days, this strange looking turtle waddles out of the river, makes a few circles, and plops back into the river. Okay, now, they had brought all the wisest people in the land there that day, so they were all analyzing the turtle was making its little circles. And so they asked the wise men, okay, what do you think those symbols on the back of the turtle mean? And the wise men said, they thought. They stroked their long beards. I can even reenact that part. They stroked their long beards. They thought. They scratched their heads. They said, finally, you know what? No clue. I don't know what that turtle's all about. I'm not sure what to make of this. But they said, do it one more time. Bring that turtle back out tomorrow. I've got a cousin who's even smarter than me, and we're going to analyze that turtle and figure out what's going on with that turtle, what it means. It could have something to do with the number of times we have to do the ritual, okay? So there they go again. The next morning, they come out. They perform the ritual a different number of times. Sure enough, here comes the turtle. Here comes the turtle. Here comes the turtle. And by this time, like crowds and crowds, hundreds of people are gathering, okay? And there the turtle's making his circles. And this time, very interestingly, a very young boy points to the turtle and screams out, I know exactly how many times we have to do the ritual. Everyone's like, what are you talking about? But you're just a child. We're the wise men and the professors and the mages, and we know exactly what we're talking about. How do you know? So my question out there for you, anyone watching, and we have a few friends on now. I see Jonathan and Kristen and Adam. We have a few friends out there right now. I wonder if analyzing the back of that turtle, if you have any ideas about what the kid may have seen. Just looking at that. Anyone out there, even Mr. Adam or Mr. Jonathan, let me know if you have any ideas about what we may be looking at. Any thoughts? I'm going to hold off here for a couple of, if there's any comments out there right now, especially want to hear from you. This is the fun part, right? Kind of like maybe start with a wild guess and we kind of narrow it down. So that boy saw something on the back of the turtle that told him, a specific number. Okay. And so let's see what we notice here. I notice that the turtle's shell seems to be kind of divided into segments. Okay, right? Do you notice that? So Miss Kristen's making a guess. She says, is it some kind of map? That's a wonderful guess. I bet there is a way you could encode a map on the back of a turtle shell for sure, because the lines on the turtle seem almost like geographical lines, right? But that's not the case. That's not the case. It's not exactly a map. Well, I mean, I guess in a way it is. It's a map to get to a number, because what the boy found was the specific number that he needed. Anybody else out there? So I also noticed, aside from the lines, I noticed that there are, these dot configurations. Ooh, Miss Kristen with another great guess. A clock. Now that would be fantastic. Now, in those days, of course, we're talking ancient China, the origin of this myth. They didn't necessarily have the clocks that we would imagine now, but they would have had sun clocks, sundials, and things like that. That's not quite it either, but it's a marvelous guess. So it does have something to do with the two hints that I gave you so far, with the way that the back of the shell is segmented, as well as the dots. Okay. Any other guesses out there? So I'm going to give you a little bit of a hint. So what I'm going to do is I'm going to kind of like redraw the back of the turtle shell a little bit, and see if we can figure out, like, make it more of a shape that we recognize. Okay. So if you've got a sheet of paper and a pencil, that's really all you need right now. We're going to keep it pretty simple. So take a close look at the turtle shell. Is that you, Laya? It looks like Laya joined yesterday afternoon at this time. Looks like she just chimed in from her mom's account. So we'll see who else is out there. So what we're going to do is take a close look at the turtle. Again, we're going to try to kind of recreate the turtle's back. All we really need is a clipboard of some kind, and this does not have to be perfect. If you're really picky and you want to use a ruler, you can. But the important thing is just we're going to replicate the turtle's back a little bit. So what I'm going to do is just draw a very simple grid. Almost looks like kind of a tic-tac-toe board, right? What I want you to do is look at this next to this and see if you can tell what I'm talking about. Like, why did I draw a grid like that? Can you kind of make a connection now? It's because what we're seeing is that the turtle shell is divided into a similar grid. Okay, and NuMinds dropped a little hint out there, if you're watching, that it does have something to do with the numbers. So I'm just going to try something. So looking at the dots on the turtle's shell, I want to kind of work with that. And so I noticed, for example, that this section has 3 dots, right? I wonder if it has to do with the number of dots or with the shape that's in the dots, but the hint here says it has to do with numbers. So let's stick with numbers for a second. And if if these lines represent the shell being segmented, then maybe the dots represent numbers, okay? So Jonathan Webster, who is a top fan of NuMinds, you should get a medal for that, just guessed 13 to 6. I'm not sure what he means by that. What I'm going to do is where we saw the 3 in the turtle, okay, which was on this side, we're going to write a 3 in our box, okay? So I think that was here, wasn't it? No, I'm flipped around. Okay, so the number 3. Now let's analyze the turtle shells. We got a 3. What's that number in the middle? Looks like a 1, 2, 3, 4, 5. Okay, and then all the way on this end, 1, 2, 3, 4, 5, 6, 7. So I'm going to go 3, 5, 7 across the middle. Okay. Okay, so is this boy saw on the turtle, these number configurations? And if so, what does that even mean? Okay, what does that even mean? So let's take another look and just continue what we're doing here. So we ended up putting a 5 in the middle. So right above the 5, what do we have? That looks kind of like 1, 2, 3, 4, 5, 6, 7, 8, 9. And then right below the 5, we have a 1 dot. So let's do a 9 and a 1. So that's where we are so far. Okay, let's take another peek at the turtle. What do we have missing? We have the corners. Okay, so let's look at the corners. In this corner, we've got 4 dots. So let's get a 4 there. In this corner, we've got this one, because this one, if this is a 9, it bled over into the next segment, right? So that looks like it's a 2. So the 4 was on the left. Then we had a 2. Okay, almost there. We got 2 more corners to fill in. 1, 2, 3, 4, 5, 6, 7, 8. Lower left is 8. 1, 2, 3, 4, 5, 6. Lower right is 6. Okay, so this indeed is what the boy was seeing when he looked at the turtle shell that no one else could see. Let's see if anyone else chimed in. Okay, so, but here's the deal. Like the boy saw that, but from this he was able to derive a special number, which gave them the answer of the number of times they needed to perform the ritual. So the question is this: how did he derive a special number from this? What are some different things you can do with numbers? Anybody out there? What are some? We've got groups, we've got rows and columns and diagonals of numbers. What are some different things we could do with them? Well, we've got a guest out there in the Facebook live sphere from top fan Jonathan Webster. Little Johnny says the magic number is 15. Where did that come from? And that indeed is the number that very sharp and observant little boy yelled out at the river, at the flooded river. Let's see if we can figure out how Jonathan and the smart kid from the story got to that number. Okay, so get on this side. So one thing that we can do with numbers is add them, multiply them, subtract them, divide them. But one rule of thumb is always start with the most simple and get more complex if and when you need to. So for me, the most simple is addition. So let's see, maybe Jonathan and the boy from the myth got the magic number 15 from adding all the numbers together. Okay, so we got 4 plus 3 is 7. Let's do plus 5 is 12, plus 7 is not, we're already over 15. So I already can tell you adding them all together is not going to give us 15. So what might give us 15? 4 and 3 is 7. 7 plus 8. 7 plus 8? 7 plus 8 is 15. Okay, so here's what I'm going to do. I'm just going to write a little equals 15 down there for this row. Now, if there's something, but that's just one row. What could we try? Maybe if, just try the other rows, other columns and rows. 9 plus 5 is 14. 14, what? 14 plus 1 is 15. So I'm going to put another 15 there. Okay, let's try that last one. We might be really onto something here. 2 plus 7 is 9. 9 plus 6 is 15. I think we are onto something, but Do you think it was just the columns that added to 15? Because my research indicates that 15 is the number that boy yelled out. The next day, they performed the ritual 15 times, and the flood subsided. So that is our magic number. But is it just that? Let's try the rows as well. 9 plus 4 is 13, and 2, 15. Okay. 3 and 5 is 8 and 7, 15. Now, okay, all the rows, all the columns equal 15. To me, that's already pretty amazing. Could it go even further? Because another thing that we could test would be the diagonals. Could it really be that magic that even the diagonals equal 15? Let's try this out. So we've got 4 and 5 is 9. 9 and 6, indeed, is 15. So I'm going to put down here. Let's try the other diagonal. 8 and 5 is 13. 13 and 2, 15. And then the low shoe magic square. It indeed is magic because every row, column, and diagonal equals the same number. So every 3 by 3, and by 3 by 3, I mean 3 grids by 3 grids. That's called a 3 by 3 magic square. So we talked about the origin from this Chinese myth, right? This legend of the flooded river and the ritual, which is pretty fascinating. But in truth, this magic square has appeared in many different cultures throughout history. This just happens to be a fun way to tell the story and kind of like problem solve right along with those ancient Chinese problem solvers who were trying to get the flooded river to subside. So this is a magic square 15. Now, if that was it, I just solved it for you. And what's the point of that? So the cool thing about the magic square, the 3 by 3 and others, is that there are multiple solutions. So this is one solution that was on the turtle's back, but there are actually several different solutions to this magic square. So here's my challenge for you. All right. So if you have some sticky notes, that's really the best way to do this. And all I did was I got 9 sticky notes. I numbered them 1 through 9. Okay. And we're just going to, this is not in magic square format, right? Because I can already tell that 1 plus 2 plus 3 is not 15. So again, I'll repeat, a 3 by 3 magic square, the magic number is always 15. That's just the law of this magic square of the 3 by 3. In a minute, I'm going to show you some more advanced magic squares, and you'll see that the magic number is not always 15 for bigger ones, but for a 3 by 3, it is always 15. So if you haven't already, get some sticky notes and a marker or a pencil or a pen, and we're going to use this as a way to quickly kind of manipulate the numbers and experiment because there are multiple solutions. I want to see how many you guys might be able to find. Okay, so here's what I'll do is I'm going to kind of give you a little head start, right? So let me rearrange these. While you're doing that, just give me a second to kind of rearrange these in a partial solution to kind of give you a head start. And then what I would really love to see is who can find solutions that I didn't even give you. Yeah, it's pretty fascinating. And when you think about how long these puzzles have been around, baffling our minds for hundreds and thousands of years. Okay, so this is a partial solution. This is where the sticky notes come in, because what you can do is you can, with the remaining sticky notes, you can kind of manipulate them around quickly and find different solutions. So this is most definitely a partial solution that you can use as a head start. So for example, like how would we go about attacking this if we just have a partial magic square completed? Like how could we fill in the blanks? Obviously we have a blank here and here, and then the whole bottom row, right? So we have to fill in all those with our remaining sticky notes. So what's that going to take? It's going to take some deductive reasoning, maybe some backwards math. Let's see. So we don't have a huge audience today, so maybe not a lot of kiddos out there, but anyone who wants to chime in with an idea, what which of these open cells would be easiest or best to attack first based on what we have. So we have one row. It does equal 15, right? 9 plus 2 is 11. 11 plus 4 is 15. So far, so good. What would be the next thing we could attack? Maybe little Jonathan's still out there and can chime in with an idea. If not, I'll just give you a moment. And if not, I can walk you to the next step. Because most people will be watching this as a recorded video, okay? Just in case. Just in case. So in a second, what's crazy to me is that I went through all my school years. You know, how many years of math classes do we take going through school, regular school, high school, college? I went through so many years of school and math classes and never even heard of a magic square until I got to NuMinds and wrote a course called Mathacadabra and started looking into these things, these little quirks of math history. And then I was like, oh my gosh, it's a treasure trove of cool math. So, all right, Jonathan has come through. He says, why not? How about the diagonal? Okay, yeah, let's try this, Jonathan. So I like that. So we've got a 4 and a 5. So if we wanted to complete this diagonal, we know that our total sum has to be 15. Guess what? Don't tell anybody this, but this is algebra, actually, algebra, because you're kind of working backwards. So we know we have 15, right? So 15 equals 4 plus 5 plus x, right? 4 plus 5 plus x equals 15. That's algebra. So let's see, 5 plus 4 is 9. 9 plus something has to get us to 15. So, oh man, got to work backwards. 9 plus something equals 15. Anybody, class. I'm just kidding. I'm good for this one. I'm just going to go ahead and jump in. So 9, we know that 9 plus 6. So I'm going to go ahead and plug in the 6. Okay. And there we have another row complete, right? 11 plus 4 is 15. So then now we have another row that has 2 done and just a third. You can use that same algebraic approach and find the missing number on this diagonal. Or now you have 2 here, so you could do this one. I wouldn't really recommend this one yet because you don't have 2, right? But once you get this one, then you could do that one and the other 3 would just fall into place. I'm not going to give you the final solution of this one. A lot of you are going to be watching this as a video, and we would love for you to comment on the video over on NuMinds TV when you watch it, and let us know how many solutions you could find and what they are. You can even post a photo of your magic square solution for the 3x3 and show us your solution. There are a lot. There's more than just 1, 2, or 3. There's several. That's pretty exciting. Okay. So there's that. You have this you can work on later, tomorrow, throughout however long you're kind of doing school from home. But some people like to dig even deeper. So I'm going to take you from ancient China. We're going to zoom up through history, and we're going to stop in the Middle Ages in Germany. There's this really cool and mysterious painting by the painter Albert Dürer. Okay. See if I can get you guys a good look at that. Okay. The title of the painting is Melancholia 1. Now, melancholia means sadness, and it's black and white. It might be tough for you to see, but there's a very, very grouchy, sad angel here, just kind of like, howdy. So that's where the painting gets its name. And when you look very closely, okay, when you look very, very closely, you can see something related to our topic today. I'm going to have to zoom in and kind of give it to you. But on the wall there, anyone see it yet? On the wall there, just kind of hidden, just very nonchalant. Like it's not the focus of the painting. It's not the center of the painting. But some very careful eyes notice that there is a magic square hidden in Albert Dürer's painting, Melancholia. But if you look even more closely, what's different about this one compared to the one that we were just working? That one was a 3x3, right? That one was a 3x3. This one's actually a 4x4 magic square. And so it's not going to be 15 anymore. It's going to be something else. I'm not going to give that to you because that's part of your extension challenge. That's part of you. That's one for you guys out there who are hungry and curious and even ravenous for more challenge. That's what I want you guys to figure out. I want you to let us know. I want you to let us know what the magic number is. So if your parents are there, we have a link to a handout that has all this. We've got the 3x3, and then on the second page of the handout that you can print right there at home, we've got some background information on this painting and a little bit of a head start. I'm going to leave my finger on it, but a little bit of a head start on the 4x4 that you can work on. The only hint I can give you is that it's not 15. And so a 4x4 square, if you count up the squares, you should be able to figure out which numbers you're going to use, because if you just use 1 through 9 on that one, it's not going to be enough, right? So you're going to need to use more numbers for one, definitely, and the magic number is going to be different. But for those of you who are even more hungry, and even the 4x4 doesn't keep you occupied long enough, this is another one. I told you in the description we were going to go all the way to meet Ben Franklin. So Benjamin Franklin, just a little reminder, is considered one of the fathers of the United States. He was here in the colonies. He had a lot to do with the development of the Constitution and kind of like the foundations of the United States, and a very multi-talented guy. He was a politician, an inventor, a writer, just about everything you can imagine Benjamin Franklin was, okay, at a very high level, okay? And they say that he was in so many meetings, especially when they were like working on the Constitution and things like this. He was in so many long meetings, he got really, really bored. So one thing he would do is he would doodle magic squares. He knew about magic squares. Even I did. And I told you, when I was in school, no one told me about magic squares. I was just doing long division and stuff. He got to do magic squares. So maybe he didn't in school, actually, because he was mostly self-taught, which is another interesting fact. But Ben Franklin got so good and so fast at magic squares that he developed one that is not a 3x3, not a 4x4. I'm going to go count it here, okay? Ben Franklin developed a magic square that was a 1, 2, 3, 4, 5, 6, 7, 8x8. And if you do 8 times 8, you'll notice that that's 64. 64 slots in the Ben Franklin Magic Square. So if you're ready for that next level challenge, what I want you guys to do is, it's in the handout, the printable handout. Check out this Benjamin Franklin Magic Square and see all the little quirks and twists that it has for you. It's really mind-boggling. It's really fascinating that his mind could so quickly mathematically design these intricate patterns that you're going to see. Okay, and finally, one more. I call this section, why should numbers have all the fun? Are magic squares only for numbers? No, actually, there's magic squares with words. And this is an ancient magic square they've actually found in some Roman ruins, okay? It's called the Sator square, okay? And if you look carefully, and this is in the handout, so you can print it and go over it with your parents or yourself and read a little bit more about it. But as you can see, words repeat across and down, okay? Going both ways. And then if you go, so you got Satar, Arepo, Tenet, Opera, Rotas, okay? But now get this. Sator, Arepo, Tenet, Opera, Rotas, that way. Going across is pretty amazing. Now, I'm just going to go ahead and say it. Word-based magic squares are very tricky, but I've done them before and I've had kids do them. They're very possible. So I challenge you, I encourage you, when you've conquered the 3x3, the 4x4, and taken a little dip into the Benjamin Franklin magic square, why not try this? Or if you're a word person, if you're less of a numbers person and more of a word person, why not jump straight to the word-based magic square, the Stater square, okay? So, all right, guys, that was from the vault, Mathacadabra. It's one of our classic classes. It's a lot of fun. That's just one lesson of many, and we have provided a link for you to download that entire first lesson that includes the 3x3 square, the 4x4, the Benjamin Franklin square, and the Stater square, the word-based one, okay? Chime in. We love to see the work that you're doing. Even if you watch this video later or next week or a year from now and you do this project, we would love to see what you've done, okay? We'd love to see what you've put it up on Facebook. Tag NuMinds, We're so proud to see what you guys are doing at home with these theme lessons that we're doing. Enjoy. Hang in there, guys.